after reading the information given in this problem, one of the things that first impressed me about the best first step to take is here in part A when it says express the area of the rectangle as a function of x. So what that signals to me is that where I see an equation for this function, I need to solve it for y. That will in turn make it a function of x. And this is that equation that I'm referring to. So after you go through the algebraic steps and you solve that for y, you should get y is plus or minus the square root of 4 minus x squared. Now that in turn can help me fill in some information on the graph of this figure. Like for instance this point. So instead of writing it as the point xy, I can now refer to it as the point x and for the y coordinate, square root of 4 minus x squared. Now notice I only need the positive value here because I am in the first quadrant. Okay, taking this a step further, let's think about how we get to points on a coordinate plane. We move from the origin, however many units to the right or left. That's denoted with this, this first coordinate. So that tells me that this length here is x units long. And then we move up or down with the second coordinate, the y coordinate. So that tells me that this length here is square root of 4 minus x squared units long. Now I can start using some geometry to help me fill in some more information. Like for instance, because these are all rectangles, here I know that this unit is x units long, or this segment rather is x units long, meaning that this longer segment across the top is 2x units long. I already have half of this segment marked, and I can see that just again based on the symmetry of this circle, that this longer segment here would be 2 times the square root of 4 minus x squared units long. Now I have a length and a width, and I can do many more geometry things with this. Like for instance, I can write an area as length times width. That's where this formula came from, or this equation came from. I can write the perimeter as 2 times the length plus 2 times the width. That's where this equation came from. And then after that, I would turn to either Desmos or a graphing calculator to help answer the rest of these problems. So like where it says, graph the function for area, what value of x is a the largest, the area the largest. So if I look at this function here that happens here on this point, I like Desmos for this because it's really clear to pick out max and mins quickly and easily. And here is that x value. And the same type of question is asked here for perimeter. Here's that maximum, and here is its x value.